hopefully you've heard of recursion from any AP computer science principal classes you've taken or any other computer science. Is a pretty interesting topic and it's pretty important. So if you haven't heard of it, then we'll just learn it today and you'll get a little glimpse about why computer science is so interesting and so convoluted at times and why people think it's hard. Recursion is one of the things that kind of blows your mind. So if you haven't already, go ahead and put your name and your period, just in case when you print it out and bring it back to school that you don't lose it with all the other ones that look the same. So there's two things that you know already. You already know what iteration is. Iteration is a technique that uses loops. It uses loops. And you already know two kinds of loops. So go ahead and take 2 seconds and figure out what are the two kinds of loops you already know. So the loops that you already know are the for loops and the while loops. And if that doesn't make sense, I encourage you to please go back and double check what is a for loop, what is a while loop, because that's actually super important. So now let's talk about recursion. Recursion is a technique that makes calls to itself. It makes calls to itself. So what does that mean? I'll give you an example down here, but first let me talk to you about base cases and recursive cases. So recursive cases, so base cases are the case that is so simple that you don't need to use any loops or repeat itself. So again, a base case is the simplest case that requires no recursion. That requires no recursion. And then a recursive case is one that makes calls to itself, makes calls to self, and it's supposed to be an and can be repeated. Okay, I'm getting used to this pad, so don't mind the messy handwriting. Hopefully you can read that, and if not, then, well, you can listen. So let's go ahead and close this off and create, actually I do need a comment, I need to create a text box. I wanted to show you an example of recursion. Okay, so again, if we have a recursive case, say with 3, and we want to add all the numbers from 3 downwards up to 0, what would that look like? Well, that'd give us 6 because we have 3 plus 2 plus 1. And that of course equals 6. So take a second, what would happen if we input to this method 4? Well, you'd simply get 4 plus 3 plus 2 plus 1, and you get 10. So now let's go ahead and think about what is the base case, what is the recursive case. Take a second and think, what is the simplest thing that doesn't need to be repeated that all of these cases have? And if you need to think about it, what is 5? 5 is 5 plus 4 plus 3 plus 2 plus 1, which is 15. So the simplest base case here would just be to simply add 1. And what is the recursive case? So again, the recursive case is something that needs to be happening over and over and over again, but it should be simplified into a call within itself. Now I'm going to give you a hint. In these cases above, we have 3, which is 3 plus 2 plus 1, let's think about what is 2. 2 is simply 2 plus 1, so 3. And what is 1? 1 is simply 1. That's it. So as you notice here, the base case, hopefully, you just simply add 1 to the rest of it. Look at here. 3 in the case of 2. 3 is simply the recursive case for 1 plus this number. Let's call this place x. So this little x right here, put it here, yeah. And we'll call this x. And here, this is simply 2 plus 3. Or it's, 2 plus x. Or it's simply 1 plus x plus, 1 plus 2 plus x. And going on here, this is simply 1 plus 2 plus 3 plus x. And as you can see, even though x changes, these things are just calling within itself. And it's almost like one of those Matryoshka dolls, the Russian dolls that kind of stack into each other. So like say, if I were to have a Jojo and I open them up, like a Recursion, you'd have a smaller Jojo right here inside him, right Jojo? So this recursive case is simply adding the number with the number minus 1. And we just need to make sure it goes all the way to 2. Because the base case, again, is just add 1. Okay. So this doesn't really make sense, which is okay. Recursion is hard. That's why I went through it quickly. I want to go and talk about what I did right here. This is simply the PDF, the notes, except in code form. So we add int public static int add together. And what does this do? Ideally, that's why I have a comment here, it's supposed to add all numbers starting at num down to 1. If you haven't heard of this, this is something called summation, or you have a summation from like 0 to 3 and it adds it all together, or you have a summation from 0 to 3 and it multiplies every time. So the sequences, series, if that sounds familiar or rings a bell, hopefully you heard of it somewhere between middle school all the way to now. That's what add together does. So I'll go ahead and write another comment, aka summation. Okay. So let's look at this base case I have right here. This is the base case. And as we said in our notes, the base case, if it's 1, what should we do? We simply return 1. Because don't forget, we need a return statement right here. It is an int, so we've just returned 1. Okay, so if this is the base case, what is this? Take 2 seconds, look at your notes. What kind of case is this? So this is the recursive case. This is the recursive case. That means it's going to call itself over and over again. And look what I did here. I simply added this number, this num, or x in our notes, with a call to itself. So the call to itself would be, I'll add together num minus 1. So the parameter num in here becomes num minus 1. So once we add the 3 together, it should give us 3 plus 2 plus 1. And if Replit ever goes, yep, here it returns 6. So let's talk a little bit about how this works one more time. First, we have 3, and we put 3 in here. If 3 is in here, we have 3 plus add together. Let me do some commenting out. So we have 3 add together with 2. And it hasn't returned anything yet. It's going to return this. But right now we don't have anything to return because it's not done. So what's add together 2 give us? Add together 2, I spelled that wrong, will give us a return. Well, first of all, is it going to be the base case? Is it going to hit the base case? No, because it's not 1. So we'll go to the recursive case. This will in turn return num, which is 2, plus add together num minus 1, which in this case is 1. But it still hasn't returned anything yet because it's calling itself once again. So what's add together 1 going to give? What's it going to give? Pause or take 2 seconds, figure out what it's going to give. Look again at the base case, see if it runs the base case or the recursive case. So as you can see, the input, the num, is 1, so it simply returns 1. Okay, and now that it returns 1, it'll go up here and return 1 here. And now, add together 2 can return 3, because this is simplified enough that it could do the math. And finally, what it does is it gives add together 2, and it returns 3 plus 3. So now we know that equals 6, and that is how add together works, and basically all recursion works.